Welcome back to the Hidden Layer. Today, we are diving deep into a new paper that might just fix one of the most frustrating things about AI today, why it's so incredibly slow.
You know the feeling, right? You ask a super complex question, and you just sit there, watching, as the model spits out its answer, one painful word at a time. It feels like this is just how AI works, but what if it doesn't have to be that way?
So here's the current reality versus the dream. On the left, that's where we are now, this slow, one thing at a time process. But the goal, what we're all hoping for, is on the right, to just generate a whole chunk of text, a whole idea in one single shot. And that dream is exactly what we're decoding today. We're looking at a brand new framework called Continuous Autoregressive Language Models, or CALM for short. And let me tell you, this isn't just some small improvement. It's a whole new way of thinking about how AI can generate text. And hey, for all you engineers and builders out there, you are definitely going to want to stick around, because later on, we're going to break down a really clever algorithm from this paper, a totally new way to control these models that you can actually implement. All right, so first, let's really dig into the problem. The core issue is something the paper calls low semantic bandwidth. Basically, our most powerful models are stuck talking through a tiny straw, only able to push out one little piece of information at a time. Man, this quote from the paper just nails it. We've built these gigantic, mind-blowingly powerful models, right? But we're still forcing them to do this incredibly simple, incredibly slow task. Seriously, it's like owning a supercomputer and just using it as a basic calculator. It's a huge waste of potential. So what's the big idea? What's the solution? Well, this is where CALM steps in. The whole game changes because instead of predicting the next word, CALM predicts the next vector. Just think of a vector as a dense, juicy package of meaning that represents an entire phrase. It's a total paradigm shift. And this diagram shows you exactly how it works. You see, the old way is this long, drawn-out sequence of tokens. What CALM does is it grabs a chunk of those, maybe 3 or 4 words, and uses a smart compressor to squish them down into a single rich vector. Then the AI's job is just to predict the next vector. Boom, you just cut down the number of steps by a huge amount. Okay, so how does this thing actually work under the hood? Let's pop it open and take a look at the 3 main parts that make this whole system tick. We're going to break this down into 3 stages. First, we have something called the autoencoder, which does the compressing. Then we've got the generative head, which does the predicting. And finally, we'll see how it all comes together in this really elegant system. All right, part 1, the autoencoder. Its job sounds simple, but it is absolutely critical. It takes a piece of text, squishes it down into a single vector, and, here's the key, it has to be able to perfectly unsquish it back to the original text. The paper shows they can do this with over 99.9% accuracy. That is insane fidelity. But wait, there's a catch. And this is a huge insight for any engineer. If you only train for perfect reconstruction, this system becomes super brittle. One tiny mistake in the vector, and the whole thing could turn into gibberish. So the real trick, the secret sauce, is making that vector representation robust, so it's a little flexible and can handle the tiny errors that are bound to happen. Okay, on to the second piece of the puzzle, the generative head. So after the main transformer model has chewed on all the context, this little module takes over. Its entire job is to predict the very next compressed vector. And crucially, it does this in one clean, efficient step. No slow, iterative process here. It's built for speed. And here you have it, the whole shebang. It's this beautiful, continuous loop. You take the text, compress it into vectors, and feed that to the transformer. The transformer then tells the generative head what to do. The head predicts the next vector, which gets instantly decoded back into text, and the cycle just keeps going. It's incredibly elegant. So this all sounds amazing, right? But it introduces a really tricky new problem. You see, normal models give us probabilities for the next word, which we use to score them with metrics like perplexity. CALM doesn't have probabilities. It just has vectors. So how in the world do you actually measure if it's any good? Well, the researchers came up with a super clever solution called Breyer-LM. Instead of looking at probabilities, it just measures how close the predicted vector was to the actual vector. And check out this chart. It shows their new metric plotted against the old school one, and the correlation is, well, it's nearly perfect. This is huge. It proves we have a reliable way to score these new models. All right, it is time to deliver on that promise from the start of the explainer. For all the builders watching, this is for you. We know how CALM works, we know how to measure it, but how do you actually control its output? How do you tune it to be more creative or more precise like you do with temperature sampling?
They came up with this method that is so simple and intuitive, it's brilliant. Here's how it works. First, you just tell the model to generate a whole bunch of options for the next chunk of text, say 100 of them. Then you just count them up, like a vote. And finally, you just pick the winner based on which one showed up most often. It's that simple.
And here's why this matters so much. For anyone who actually wants to build with this technology, this gives you a real practical knob to turn. You can now control that classic trade-off between a model that's wild and creative versus one that's safe and coherent. And you can do it all without ever needing messy probability calculations.
Okay, let's zoom all the way out. What does this really mean for the future of AI? Because this isn't just about one specific model. This paper points to a completely new direction for making AI more efficient.
I mean, the results really do speak for themselves. This chart shows a CALM model getting basically the same performance as a standard transformer. But look at the cost. We're talking 44% less compute for training and 34% less for inference. That is a massive efficiency gain. You get the same bang for way, way less buck. And this, right here, is the big takeaway. For years, the way we've made AI better is just by making it bigger. More data, more parameters. This paper gives us a new lever to pull: semantic bandwidth. Instead of just scaling up the brute force, we can now scale up the amount of information the model processes in every single step. It's about working smarter, not just harder.
So this leaves us with a really exciting question. We have been stuck in this one-word-at-a-time world for years. But now we can see a path to a much faster, phrase-by-phrase future. So what do you think? Is scaling up the semantic bandwidth the next great leap forward for making AI bigger, faster, and smarter? I'd love to hear your thoughts down in the comments. Thanks for watching.